Okay, calculus students, let's look at problem 10 on WebAssign 11. If you can do problem 10, you should be able to do problem 11. It's, same but slightly different. So number 10 is they define this function here. When x is not 0, which means when x is bigger than 0 or less than 0, it's this. But only when x is 0, they're going to say it's 33. Okay, so that says, seems like a reasonable thing to say. So this function is defined everywhere. Now, here's the deal. As x approaches 0, okay, let's say in the limit that this function, that x approaches 0 of this function goes to 33. Because this sine of 6 over x goes back and forth forever, because as x goes to 0, it goes to infinity, and every 2 pi it goes back and forth. So as you get closer to 0, it wiggles back and forth infinitely fast, but the 0 here makes it go to 0, because the biggest this can be, it's always between -1 and 1. Sine is always between -1 and 1. 0, or 0.0001 times 1 is 0.0001. So this is the squeeze theorem thing. Even though this goes back and forth between 1 and -1 forever, the 0 wins and makes it go to 0. And so when this is 0, it goes to 33. So when the limit as x approaches 0, our function goes to 33, which is what it is at x equals 0. Which means it is continuous, because the function, as it goes down to there, hits where it's aimed directly towards what it is at x equals 0. So this is a continuous function. The question is, does it have a derivative at x equals 0? Okay, and that's what we're going to do here. So now if x isn't equal to 0, what's the derivative? Now the derivative at x equals 0 is derivative of 33 is 0, right? The slope at x equals 0 is 0 because it's a constant, and the derivative of a constant is 0. But when x is not equal to 0, what's the slope? So we have to use the chain rule and the product rule. Okay, so take the derivative of this. Now the derivative of 33 is 0. That's easy. So we can ignore that. So what is the slope of that? So it's the derivative of the first times the second. That's the product rule. Derivative of x is 1. So it's sine of 6 over x plus the first one, x, times the derivative of sine of 6 over x. Now I'm going to write sine of 6 over x as sine is 6x to -1. That's just easier. So we take, okay, so now we have to use the chain rule. The derivative of sine of anything is cosine of that thing. So it's the first times the derivative of the second, so that's cosine of 6 over x, times the derivative of what's inside. What's inside is 6x to the -1. The derivative of 6x to the -1 is, so it's times, derivative of that is -6, right? -1 times 6 times x to the -2. Be careful, right? It's not -6, it's times -6 x to -2, right? Because the -1 makes it -6, x to -2. You could also use the quotient rule and do that way, but I think this is easier because it's just so simple, just x to the -1. You can just use the power rule for that, but you could use the quotient rule for that. Let's rewrite that because this is a mess here. 6x to the -2, let's rewrite this one. That's like, this is x cosine, -6x, right? The -6 we can put in front, times cosine of 6 over x with an x squared in the bottom. That's what x to the -2 is. Well, notice that x cancels, we're left with an x in the bottom. So the final answer, what I would put into Desmos is, put into WebAssign is sine of 6 over x minus 6 cosine 6 over x divided by x. Okay, that's the derivative. That's f prime of x. So I'm going to erase all this here because we have our answer. That is f prime of x. Our derivative is sine 6 over x minus 6 over x, 6 cosine 6, yes. Okay, so we had to use the chain rule and the product rule to get that, and I think that's right. Okay, So again, this should work. Be careful with the -6. Probably have to use parentheses around it. You could type that in next to the -2. I mean, you could do that. That works. But this helps us understand it a little bit better, writing it like that. So it's always good to do. Okay, now we have a bunch of questions, multiple choice questions, so you don't want to get these wrong. So let's see. Limit as x goes to 0 of f of x. Okay, I already said that. As the limit of x goes to 0, it goes to 33. Now, okay, of f of x. So, yeah, it goes to 33. Which means it goes to what it is, and that's when something is continuous, when the limit as it approaches something is equal to the function at that thing. That's the definition of being continuous at a point. If the limit of the function, when it approaches 33, and it is 33, so it's continuous. So here, the limit there, okay, I'm gonna keep this here, and I'll just scroll up here to get this out of the way. Hopefully I can do this without going to my computer. I know I always have trouble doing that. Let's go to my computer. Okay. So the limit as it goes to that is definitely 33. We already said that. Okay. So that's just what the function approaches, x approaches 0. And it approaches 0 from both sides, it goes to 33. Because it goes to 0, whether it's positive or negative, it still goes to 0. So from both sides, that means it does exist. Does not exist means you get a different one. Because, right, this doesn't have a plus or minus. As we go from both sides, it goes to 0. And let's look at that again to make sure, because that's the tricky part. When x is negative, still goes to 0. When x is positive, it goes to 0. This just goes to -1 and 1. So yeah, it goes to 0 from either side, which means we're left with 33. So, yep. So it does exist, and the answer is 33. Okay, now this next one, notice this is the derivative at 0, because remember the derivative formula is limit as h approaches 0 of f of x plus h minus f of x divided by h. Here x is 0. When x is 0, you just have an h in it. So this is the derivative at 0. So this next one, f prime is 0, it's the same answer. Okay, they just want you to see that it's the same thing. This means the derivative at 0, and this is a definition of the derivative at 0. So it's the same answer. So if we do this one, we automatically get 3. They're always going to be the same. Just different notation, which is, it's a good problem. They're just trying to get you to understand that. All right, so what is the derivative at 0? This is the derivative. Okay, so does this exist at 0? Is there a slope at 0? Okay, is there something we can automatically say, does this exist at 0? Now, let's see, it exists everywhere else, but at 0 we're dividing by 0 here, and we're dividing by 0 here, we're dividing by 0 here. It just seems like this should not exist, right? But that doesn't mean that it doesn't exist. To not exist means that as you go from one side, you get one answer, and as you go from another side, you get a different answer. Okay, so let's see if that's the case here. Right, because otherwise it could be infinity or negative infinity, but if it's both of those, then it does not exist. So let's see. Sine is an odd function, which means that, and this is really important, okay, put this in your bag of tricks if it's not there already, sine looks like this, right? Sine looks like this, which means it's the same value on both sides of the y-axis, but it's negative on one side. It's always the negative of it. It's the same value, it's always 0.2, but on one side is negative 0.2, the other side is positive 0.2, so this is called an odd function. Which means as we approach it from this way, sine is going to be negative. As we approach it from this way, sine is going to be positive. Okay? So it's not going to exist. We're going to get a different answer. And same thing with this. This is an odd function because cosine is even. Okay, cosine is an even function. So cosine looks like this, right? It's symmetrical about the y-axis. So it's the same thing on both sides. If x is right here, we have the exact same value. So it is an even function. So if we just had a cosine and we're going this way and going this way, it is approaching the same thing. But cosine over x is odd because x is an odd function, right? 1 over x, x itself, x on one side is positive, x on the other side is negative. So this makes it odd. So we have an odd function minus an odd. Even if this one is even though, because this one's odd, we're going to get a different answer. It turns out they're both odd functions. So this one, this does not exist, okay? Because we get two answers. As we approach from this way, we're going to get something, a different answer as we approach from that way. So same thing here, because it's the exact same thing. Okay, so this really has to do with odd and even functions. Now, what if this was x sine x? Then this would be an even function, because an odd times an odd is equal to even, and then it's the same on both sides. Now this one, if this was like an x squared in the bottom, then it would also be even, because cosine is even, x squared is even, because x squared is the same on both sides, right? X squared looks like this. It's the same on both sides, so it's an even function, just like cosine is. So then it would exist at x equals 0. So you got to be careful of that. And I think that's what the next one, I'm giving you some prelude to the next one here, because it's something like that. Okay, let's go down here and finish this one off. So some other questions here. F of x is continuous for all x. That is true, because we already said that it approaches 0, as you go from both sides, it approaches 0. Sorry, it approaches 33. And it's defined to be 33 at x equals 0. So it approaches what it is, therefore it's continuous. However, it's not differentiable for all x, because at 0 it's not differentiable, because if you go from both sides, the slope is different. The slope is one way on one side, the other way on the other side. Okay, that's that one. That's number 11. And number 12 is very similar, but slightly different. So look for odd and even functions. Okay, so that's the important part here. Look for odd and even functions. Sorry, that's number 10. So number 10. Then number 11 is slightly different. It looks similar, but slightly different. Let me see number 11 looks like. Okay, but it's got different numbers, like an x squared there. That makes a big difference. So, okay, good. Hope that makes sense. Good luck on those. Good luck on number 11. I think you can do it. Awesome.